Topic 3.6 is over higher order derivatives. And so I'm just going to start off with some notation. So we're going to go through Newton's notation, Leibniz notation, all the different ways that you can represent a derivative. And so today we're going to be taking second and third and fourth derivatives, and those are used to tell you different things about the function. So don't ever forget, the first derivative gives you the slope of the function. All right, so but we can take the second derivative also, and that notation is just going to be y and then 2 little primes. And then third will be 3. And then fourth derivative, we don't do 4 little lines or like the IV. What we'll do is in parentheses the number 4. And so after that, we're going to do the fifth. It'd be the same thing, in parentheses the number 5. Okay, and this one is similar. All right, for the DUI dx is kind of different. We're going to do d2y over dx2, and that always bothers people that it's not consistent on the numerator or the denominator. So it's just one other thing to remember. All right, and then this one is similar. There's lots of ways to represent the derivatives because lots of people contributed to calculus. And this last one we don't use as much. I don't know if you guys have ever seen this notation, another derivative notation. All right, now finding second derivative is hopefully what you would think it is. So the derivative of the derivative. So the second derivative is the derivative of the first derivative. So I would first find the first derivative. And with polynomial functions, it's not hard to do. It's just a whole bunch of power rules. The other types, it does get a little more challenging. All right, so that's the first derivative. So then if I want to find the second derivative, I'm just going to go and do the power rule on this one. And that's it. And then if the directions are to find the third derivative, I would do the derivative of the second derivative. Okay. All right, this next one is going to be a little more challenging because if you notice, we're going to have to do the product rule. And it involves some trigonometry, which is not too terrible. So we'll start with the first derivative. By using the power rule, we'll leave theta alone, multiply by the derivative of sine of theta, plus leave sine of theta alone, multiply by the derivative of theta. All right, and then there's really not a lot to do because we're just multiplying by 1 over there. Okay, that's the first derivative. And then for the second, we'll find the derivative of that. And again, I'm going to have to do the product rule. So we'll leave theta alone, multiply by the derivative of cosine of theta, plus leave cosine alone, multiply by the derivative of theta, plus, so all of that was that one. And then I need to find the derivative of sine, which is cosine of theta. Okay, and then for this one, I'm going to combine my like terms and kind of multiply here. So theta times negative is going to be negative theta sine of theta. And then this is cosine of theta plus another cosine of theta is plus 2 cosine of theta. All right, that's my second derivative. All right, and then we can also recognize the graphs of the second derivative too. And so one thing to keep in mind, like we just did a polynomial function where we started with a quartic. The first derivative moved down to cubic. The second derivative moved down to quadratic. If we took another derivative, it would be a linear. And if I took another derivative, it would be the constant function. So for polynomial functions, every time you take a derivative, the degree goes down by 1. So that, for me, makes it kind of easy to recognize what was the original, and then the first derivative, and then the second derivative. So you start off with the polynomial function that has the most turning points, really. So the one that has the most turning points is going to be the original function, f. That's a cubic function. And then cubic is going to go down to quadratic, so that's going to be f prime. And then quadratic would go down to a linear, so that's going to be f double prime. All right, so that's something I want you guys to be able to do, especially with polynomial functions. Figure out the graph of f prime, and f double prime. All right, example 3 is a little bit more difficult. We have the graph of f, and we're going to sketch the graphs of f prime and f double prime. So let's start with f prime, and don't forget, f prime, the graph is the slopes of f. All right, now I know when the function has a maximum or minimum, that is an important part for the slopes. And so I can see that happens at -1/2. So I'm definitely going to put that in my table. And then we'll also put points around that. So -2, -1, 1, and 0. All right, so at 1/2, when there's a maximum, or if there had been a minimum, that's always going to be a horizontal slope or slope of 0. Okay, and then at 1, so 1 would be about right here. I'm just going to draw a little line to represent a slope. I would say, just estimating, that slope is about -1. All right, so then at 1, that's going to be the same slope. Oh, wait, no, hold on. That should have, I got my numbers backwards. Okay, so at 0, that's going to be a slope of -1. And then at 1, that's going to be a slope of 1. -1. All right, then at -2, that's the same steepness as 1. All right, and those are definitely steeper than 1 and -1, sorry. Those, I would guess, would be about 3 and -3. All right, so when I go to graph these slopes, those are just ordered pairs. So -2, 3, -1, 1, 1/2, 0, 0, -1, 1, 3. All right, now, because that was quadratic, this one should be linear. Now, don't freak out. Whoa. If you go to do your graph, I don't know why it gave me an arrow, but that's nice. If you go to do your graph and it isn't linear, it's fine. Don't panic. Try to make it linear because it should be. But we're just learning this stuff. All right, so now let's look at the slopes of f prime. Okay. So let's just do -2, -1, 0, 1, and 2. So since it's linear, those slopes should be the same. And if I was estimating right, it looks like down to right 1 everywhere, down to right 1. So that's the slope of -2 everywhere. All right, so then that's just going to be a horizontal line when x is -2. All right. So your assignment is on page 127, 92, 94, 98, 100, 102, 105, 108 through 110, and then 112. And if you guys look at the back of this sheet, the graphs that you need to use I have graphed on the back. So you can, instead of like trying to freehand them, you can just use those. So it's fine with me if you try to do all your homework on the back. It doesn't matter. I don't know if you can fit everything, but definitely do those graphs back there.